All right, lesson 24.4, graphing cube root functions. So again, we're looking at inverses. So a cube, when we looked at polynomial functions, remember we talked about odd functions, how when you graph an odd function, if it's on the negative side over here, then it's got a negative value, and then a positive side, it's got a positive value unless it's reflected. And again, we're going to look at transformations on these. So at a cube function, and here they've given you an example of graphing a cube root and a cube. And again, here's the line y equals x. Since they're inverses, remember it has to go right through the middle, and all that you're doing is you're switching the x's and y's for each other to find the inverse function. So when you talk about a cube root, now you got to start thinking about reference points for cube roots. So again, the values they give here, and they don't call them reference points, they will in the Algebra 2 book, but these reference points are the basic ones we're going to use to do all the transformational graphs. So you can take the cube root of -8. Cube root of -8 is a -2. So in this case, you can have negatives. It's not like doing square root. You can't take the square root of a negative number. Cube root of -1 is -1. Cube root of 0 is 0. 1 is 1, and then 2. So really all you've got, there's some symmetry involved here. The values here are the same here, except they're negative. So if you graph those points, it's kind of like your starting point here, beginning point. Not really, but that's kind of how we think about it. You go over 1, down 1, again, pay attention to your scale. Over 1, up 1. And then you go to the left 8, and then down 2. Go to the right 8 and up 2. So the function looks like this. Now the good thing about a cube root function rather than a square root, the domain and range changes based on the shifts. With a cube root function, it really never ever changes. The domain is going to be -infinity to infinity. If you use interval notation, sometimes you're going to see this, all real numbers. Different notations here for it. Range will be the same thing, all real numbers. And again, that's because when you graph a cube root function, it's always going up, it's always going down, it's always going to the right, it's always going to the left. So what about transformations with cube roots? So let's look at this particular example, example B. Again, I'm going to ignore the graph of points here. All I'm going to think about are my basic reference points and use those in relationship to graphing. So remember, we had -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So we go back up here to our transformations. When it's with the x, it's not what you think, so that means I move to the left 2, and this means I move it up 8. So what they've done is they've graphed the parent function. So what I'm going to do is go left 2 and up 8, and that's where my quote-unquote starting point is. Now all I do is I take care of my shifts or my reference points. So when I go to the left 1, I go down 1. When I go to the right 1, I go up 1. When I go to the left 8, so I go 8 from here, so 2, 4, 6, 8. Then I go down 2, and then 8 to the right here, so 1, 2, 4, 8, and then go up 2, and then graph my function again. And again, the good thing about this is domain is going to be -infinity to infinity. Again, if you're using interval notation, and range, same thing. I don't care what notation you use. I think the book is going to use interval notation. Over here, it's doing inequality notation, which is the same thing. The only difference is it uses the inequality symbols here. And it has to use the value of, or the variable x and y to denote domain and range. So here's a year term problem, same thing. Look at my shifts, go to the left 3, go down 6. So I'm going to go left 3, down 6. That's going to put me here at kind of my starting point. Then I use my reference points again. So when I go to the left 1, I go down 1, and then when I go to the right one, I go up 1, and then when I go to the left 8, I go down 2. So left 8, 1, 3, 5, 7, 8, and then down 2 would put me here, and then go to the right 8. Now again, this is all from your starting point here, the red point. So I go over 1, 3, 5, 7, 8, and then up 2. It's not very good. It's a little better. And then graph my function. And then again, domain, negative infinity to infinity, and range, negative infinity to infinity. Now we're going to look at except when we do vertical stretch or compression. So in this case, we're multiplying by a positive 2. Since it's a value greater than 1, that's going to be a vertical stretch. You can look right here, there are no shifts. So my reference point is still here. My red dot is. So usually my next reference points, I go to the left one, and then I would go down 1. But because I'm multiplying by 2 here, that's not going to be -1, but it's going to be -2. So I go to the left one, and then I go down 2. Same thing, when I go to the right one, usually I go up 1, but again, because I'm multiplying by 2, that's going to be 2. So I go to the right one, and then up 2. And the next one, reference point, have -8, and then I go down 2. But again, because I'm multiplying by 2, I go to the left 8, which would put me here, and then go down 4. Same thing, go to the right 8, and then go up 4, since the other reference point is 2, and multiply 2 by 2, and we get 4. So then you see my graph has been vertically stretched. It's gotten taller. Why? Because we multiplied by 2. Now, again, as far as domain and range, very easy. Domain, always going to be negative infinity to infinity. Range is going to be negative infinity to infinity. Only time domain and range can change for a cube root function is if it's a word problem. So for this particular, you are doing page 1197, and you're going to be doing numbers 1 through 22. Numbers 1 through 22.